Hi, this is Tom Bands at Anne Arundel Community College, and I want to talk about the Mechatronics trainer. This trainer is the Wonka Machine Mark II, and in this video I want to talk about the machine itself, the control panel, and the Click PLC software that we used, and also the Wonderware HMI. There are also two motors. The trolley motor is driven by a controller with an encoder, and the candy dispenser has a motor on it. There are also two pneumatic pistons, one for the cup dispenser and one for the sorter arm. The machine consists of the cup dispenser, the candy dispenser, the sorter slots, and the trolley. Let's talk about the cup dispenser. That's where the process starts, over on the left side, and that's where the cups are stored and they're dispensed out onto the trolley. The cups themselves are either black or white. Here's an example of a white cup, and here is an example of a black cup. The color of the cup is sensed when the cup gets to the candy dispenser, and then what happens is different amounts of candy are dispensed to the different color cups. Slightly less to the white cup, slightly more to the black cup. And then the trolley moves the cup to the correct slot, the sorter slot, and the first sorter slot is for the white cups. The second sorter slot is for the black cups, and they're placed in the correct slot to be handled downstream. So for the control system, let's look at the control panel. So you see there's a power on-off switch. Pretty obvious what that does. There's a start push button, a stop push button, and a reset push button. They also do those functions. There are three toggle switches to the right with their indicating lights there. The first one is labeled normal or manual. Normal control is with the PLC in control of the machine, and it's doing everything. Manual control is if for some reason you need to get the trolley into a certain position, you can put it in that mode and use the push buttons to drive the trolley to the left or the right, overriding the PLC. The second toggle switch is labeled normal or continuous. Normal mode is it delivers one cup and goes through the entire cycle with one cup and then stops. In continuous mode, it delivers each cup and then goes back to retrieve another cup and just continues on. The third toggle switch is labeled force sensor or one sensor. Now these are the sensors that are along the trolley track, and there are four sensors. There is in the force sensor mode, the PLC uses those four sensors to know where the trolley is and to tell the machine what to do. In the one sensor mode, it only uses the leftmost sensor over by the cup dispenser as kind of a home base, so when it gets there, it sees that the trolley is there, and from there it uses the motor encoder to know where the trolley is. There's also a cup color sensor that can sense the color of the cup, and that is right at the candy dispenser. So another item that you'll notice here is the light tower. The way it's set up with this machine is that when you're ready to start, you press the start button one time, and it gives you a lamp test. All three lamps come on for 3 seconds, and then the green and yellow light go out. It's just the red light that tells you that the process is ready to go. And you press the start button a second time, and the yellow light flashes on and off for 5 seconds, telling you that it's getting ready to start. And then when the process begins, the green light comes on and remains on throughout the process. The PLC used with this machine is a Click PLC from Automation Direct. So of course we use that software. The Click PLC software has some interesting features. It does have ladder logic, so a lot of the stuff looks familiar if you're familiar with ladder logic. But for routines and subroutines, it has these features called sequencers, or they call them drums also. So you can get into one of these sequencers and do a routine, and they do have a lot of flexibility. You can have jump commands within the sequencer, so you can move to a different line if you need to for different operations. There are two types of drums. I use the event-based drums for this machine, but they also have time-based drums, and we weren't able to put any of those in this piece of software. But elsewhere in the program, I used some counters, timers, and move commands to control the operation of the drums and other aspects of the operation. So there's a lot of support operations down below the drums. So to set up a drum in Click PLC software, you place a drum into the program and double click on it. You get this setup screen, and looks like a lot going on here, but it's actually pretty simple. Up here in the upper left hand corner, you see there's a box. You can choose the base, so you have the time base or the event-based drums. We've got exclusively event-based drums here in this program, so we'll be working with those. Now you choose the number of steps here, and you just click up or down to increase or decrease the number of steps, and the number of outputs works the same way. We'll look at those, and the output status here, black box is on, white box is off. So some other features that are kind of nice here, current step, and this one is DS1, so that outputs the DS1 whatever your current step is. So if you want to use that, synchronize something, that's how you do that. And then for the load new step number here, if you want to jump to a different part of the drum, you put the new step into DS4, and then when you enable the new step, then it'll move to that step. Then the completion flag, when the drum is done, it outputs to C10. Okay, then we have the grid, and across the top, you see we have the ability to have 16 outputs, and the steps, they're the inputs, 16 of those possible also. Now the inputs, you input right here, whatever bit you want to be your input, you put its address there, and down at the bottom, this is where you input the addresses to the outputs. And the way this works is when the drum is first enabled, the first line is enabled, and so the outputs with a black box there turned on, and so you see here 1, 2, and 3 are turned on. We look down here and it is Y1, Y2, and Y3, and this is the drum for the startup light. So the first thing that happens is we get the lamp test, and all 3 lamps light up, and that's what we're doing here. And then so that happens for 3 seconds. When the timer times out over here, then it moves to the next step. Now, one of the things that I found a little bit difficult to get my head wrapped around, and I had to use notes on this. So it starts here, and then whenever this event occurs, then it moves to the next step. And then when this so you're on this step, when this event occurs, it moves down to the next step. So you're always moving to the left and down to the right, over to the left and down to the right. So just remember that's how that works. And yeah, so the next step, anyhow, the next step you remember was after the lamp test, the red light came on. That's output 1, and then the yellow light came on. And what these 2 are doing is they're bits going to 2 timers that are set for a half a second each, and so that's how we got the flashing of the yellow light. So this is, the light is on, this is, everything is off, and we alternated between those 2 steps. And then we went down, and when that was done, the process started and the green light came on. So that's a basic overview of setting up a Click PLC drum.
So when you're finished with the drum setup screen, you come back to the program, and this is what the completed drum is going to look like. Now this is slightly different than what we set up in the previous section, but it's essentially the same thing. So first of all, let's look at the inputs and the output to and from this drum. So we have 3 inputs over here and 1 output right there. And the 3 inputs are, first of all, the enable input, and that starts the drum process. And what that does, it goes to the first step, and it outputs the marked outputs out to the program. The next input is the reset, and the reset resets the drum and clears the complete instruction also. And the last input is the step number input, and when that goes true, that sends the drum to the step that has been input here at the new step address. Here we have the address is DS4, and so you can input an address in there and make this step number instruction go true and send the drum immediately to that address. So that's kind of nice as a jump routine or a subroutine. Then the output is the complete bit. So when the process, the drum process is done and the last event has taken place, then this complete bit goes true. And then of course you can use that to move on or whatever you need to do. Okay, so now this new step and the step number here, you can either place an integer there if you want to go to the same step all the time, or you can have move instructions outside in the program, and depending on what you want to have happen, you can move various integers into the new step position, and actually jump to different parts of the routine if you want. And the current step. And the current step right here, this tells you the current step. This address tells you the current step, and you can use that if you need to. Then let's look at other stuff inside the drum here. Here we have the output numbers. Here we have the input, the step numbers. Here's the grid. Here are the actual outputs. We're going to be looking at this. Here are the inputs to move to the next step. So what we have here for outputs is, number one is the red lamp. Number two is the yellow lamp. Number three is the green lamp. Number four is T2. Number five is T3. So let's see what goes on here. We start the process, we enable it, the first step goes true, everything here in the first step that's marked as output. So the red light, the yellow light, and the green light do in fact go on, and they stay on until timer T1 times out. Right now it's set for 3 seconds. So then when it times out, it goes to step 2. Step 2, only the red light is on now. Okay, and that stays on until this counter, counter 8, that counts the number of times you've pressed the start push button. So the first time you get this particular drum going, and it waits, and it does the lamp test. Then before it starts the process, it waits for you to press the start push button a second time. So it sees that, and then it moves down here. And here you see now we go through the yellow light flashing process. So the yellow light goes on right here, and timer T2 starts. When timer T2 is completed, it goes down to here, and now you see there's no lights on. Timer T3 is energized, and when it times out, what happens is, you'd think we would move down to the next line, but we don't, because what supersedes that is we energize the step number command, and it sends the number 3 up to the number 3 is permanently in this new step address, so it sends the drum back to step 3. Now step 3 is turn the yellow light on again and start T2 again. So then the yellow light comes on for T2 time, and this process repeats itself. It goes out for T3 time, and that's how you get the flashing. Then we count the number of flashes, and then it moves down to this step here. It disables the step number command, so it allows the process to go down to step 5, and then we can move on. And then at step 5 also, the drum completion bit is energized. So that's how we complete the process. Working with the Wonderware was very interesting. When I came into the project, much of the basic work had been done on the Wonderware. The graphic of the machine was made using a photo. The control panel, the light tower, and the moving arms were designed in Wonderware itself. Some of the lights worked and the auger moved. I was able to show the trolley moving and the cups appearing, as well as getting the control panel to operate. Back in the Click PLC software, you need to add the input instructions in the appropriate place, and you can link directly to the outputs. Then you need to find the Modbus address of the bit that you're interested in. You do this by opening the address picker and clicking the box Display Modbus Address down the lower right hand corner. The Modbus address column will appear. Go to the bit that you want to link to Wonderware, and its Modbus address usually is the 4 or 5 digit number outside of the parentheses. Now back in Wonderware, go to the left hand side and open up the main driver sheet, and then you want to put the Modbus address code in the IO address box for the tag that you'll be using for that bit. That links the object in Wonderware to the correct bit in the PLC software. Then when you have everything set up correctly, you can operate the buttons with a computer cursor, or it's really cool if you have a touch screen, you can operate the buttons with your finger also. So that concludes this video. It was a lot of fun doing this project and making this video too, and thanks a lot for watching.